So one other thing that you'll be responsible for in 8.4 is making polar graphs from polar equations. So there's a handout in Canvas that looks like this, and it's 3 pages, and the first page gives equations that look like this form, where we have r equals a plus or minus b cosine theta or sine theta. So notice under each one of these we have a equals 1, or a over b equals 1, or a over b is between 1 and 2, or it's less than 1, or that's greater than or equal to 2. So a and b are the numbers, the constant by itself and the coefficient of sine and cosine, and they're both considered to be positive. The plus or minus is not tied. It is, but b is just the number. It doesn't include the plus or minus out front. So depending on what the ratio of a over b is, that dictates which one of these shapes is going to look like. So let's do an example. Let's do r equals 2 plus 2 sine theta. So since we know it's going to look like one of those 4 shapes, this is A, this is B, so A over B equals 1. So it's going to look like this shape. If we zoom in a little bit, this kind of looks like a lily pad, and it touches the origin. This one also looks similar to a lily pad, but it doesn't touch the origin. This one touches the origin, but it has an inside loop. And then this one is a little bit more circular. It's kind of like this one, but it doesn't have that pronounced crevice in the backside, the little dip in there. But this one is going to resemble this. Now, while I say it resembles it, it might not be turned the same direction as this one. So the way we figure that out is we want to plot the 4 quadrantal points. And what I mean by that is the points in a direction of 0, 90, 180, and 270. So we substitute each of these angles in, and we find out the corresponding radius. So when theta is 0, we have 2 plus 2 sine of 0 degrees. So sine of 0 is 0. 2 times 0 is 0. 2 plus 0 is 2. If we put 90 in, sine of 90 is 1. 2 times 1 is 2. Plus 2 is 4. And then real quickly, if we put in 180, sine of 180 is 0, so we get 2 plus 0. 270, sine of 270 is negative 1, so we get 2 times negative 1 is negative 2, plus 2 is 0. So if we pull up a grid, then let's plot each of these, and let's shrink our graph just a little bit so it fits on our page better. So in a direction of 0 degrees, our radius is 2. In a direction of 90 degrees, our radius is 4. 2 here, and in a direction of 270, 0. So the question is, from those 4 points, how are we going to draw this graph? So notice these 2 points are equidistant from the origin. This point is the maximum radius, and that's the minimum radius. So it's going to have this shape to it, but it's going to be turned because this is a maximum radius here. So here's our minimum radius, and then our radius is getting bigger and bigger until it hits the maximum radius, and now our radius is getting smaller until we get back here and our radius is back to 0. And I'm not going to require it to be perfect because mine's not perfect either, but it does need to hit those 4 points, and it does need to have that general shape. So let's do another one. Let's do r equals 2 minus 3 sine theta. So if we do this one, If we put a 0 in, sine of 0 is 0, so we get 2. If we put 90 in, sine of 90 is 1. 2 minus 3 times 1, so 2 minus 3 is negative 1. Sine of 180 is 0, so 2 minus 0. And at 270, sine of 270 is negative 1. So negative 3 times negative 1, that's positive 3. 2 plus 3 is 5. So those are our 4 quadrantal points. Now if we look at our graph for our formula, if A over B is less than 1, and that's what we have here, A over B is less than 1, then our graph is going to have this general shape. It's going to have this inner loop. Notice there's not a point in the opposite direction of this, and for our quadrantal points, none of those are actually at the origin. If we go back and look, none of our quadrantal points are at the origin. That doesn't mean there's not a point at the origin, it's just not one of the quadrantals. So these 2 points are also in the same direction. Well, how do we get 2 points that are both in the same direction? Notice this negative radius. If we're in a direction of 90 degrees and we go a negative radius, we're actually going down. Well, we also have another point that's down, this one. So that's how we end up with 2 points in the same direction. So let's construct a graph. Here's the grid. So if we plot our 4 quadrantal points in the direction of 0 degrees, we're out 2 units. In the direction of 90 degrees, we're negative 1. So instead of going up, we actually go away from 91 unit. 180 is 2, and 270 is 5. So these are those 2 points that are in the same direction that give us our outer and our inner here. So if we use that to make our sketch, this is our inner loop right here. So we could sketch it first if we wanted to, and then we could continue and sketch the larger one. And that'd be a rough sketch for that. So that's just plugging in 4 angles to get 4 points, and then plotting those points and understanding what the general shape is. If we didn't know the general shape, then we wouldn't be able to make that plot with just 4 points. We would have to make a whole table full of points. But if we know the general shape and know some points, then we can make that graph very quickly. So some other special graphs that are on this list are ones like this. 3 cosine 5 theta. And let's not do 5, let's do 3 theta. So if we look on our handout, ones of that form are on the second page. If we have a number times cosine 3, or any number theta, a number times cosine of any number of theta, if the coefficient of theta is odd, then that's how many petals we have. If the coefficient of theta is even, we have twice that number of petals. So for this one, since that number is odd, we have 3 petals. And one thing that's convenient about the cosine ones, these are called roses, is that the tip of the first rose starts in a direction of 0 degrees. Now quickly, let's look at why that would be. The tip of a petal is when the radius is as large as possible. So the question is, how do we get the radius to be as large as possible? The coefficient out front is not changing. This part is what's changing. Well, how do we make that as large as possible? It's when that is equal to 1. Well, when is cosine equal to 1? Well, as you make multiple rotations, there might be more than one place. But in the first rotation, the only place where cosine is equal to 1 is when our angle is 0 degrees. So not necessarily theta, but whatever our total angle is when it's 0. Well, notice regardless of what this coefficient is, when we divide 0 by that coefficient, theta is going to be 0 degrees. So in other words, we get a maximum radius when cosine is 1, and that's going to occur when we plug 0 degrees in for theta. Regardless of what this number is here, if this value is 0, anything times 0 is 0. Cosine of 0 is always 1, which is the maximum output for cosine. Remember, the range for cosine is from -1 to 1. So the tip of our first petal is tip is in a direction of 0. And we have 3 petals, and notice they're evenly spaced. Let me close this window. Notice those are evenly spaced. So that gives us more information. If we have a total of 360 degrees, and we have 3 evenly spaced petals, then 360 divided by 3, our petals are 120 degrees apart. So if we know where the first tip is, each subsequent petal will be rotated 120 degrees from there. Also, the maximum radius is going to be given by that coefficient. Notice if cosine is as big as possible, it's 1. 3 times 1 is 3. So if we compile all this information, we can make a sketch of this rose. So our first tip is in a direction of 0 degrees, so straight to the right, and it goes out 3 units. And then there's 120 degrees between petals. So if the first one is at 0, if we add 120 to that, then we're at 120. And it has the same distance, the same radius. If we rotate another 120, that gets us to 240. And all tips are at a radius of 3. If we add another 120 to that, that gets us back here. So our petals on our rose are going to look like this. So there's a 3-petaled rose. Each tip is 3 units out, 120 degrees between the petals. So let's do another one of those. Let's do r equals 4 cosine. Let's do 4 theta. So our first tip, we know, is it going to be at 0 degrees? Because if we substitute 0 in, 4 times 0 is 0. Cosine of 0 degrees is 1. That's as big as cosine can be. And also notice that when cosine is 1, 4 times 1 gives us a maximum radius of 4. Since the coefficient of theta is even, then we have twice that number of petals, so 8 petals. If we have 8 petals and they're evenly spaced, if we divide 360 by 8, then that's 45 degrees between petals. So we know where the first petal starts. We know how what the radius is there. We know the angle between petals. So we can make a pretty good sketch of this rose. So let's get our coordinate system. So our first one is in a direction of 0 degrees with a radius of 4. And then we rotate 45 degrees to get to the next one. So 45 degrees gets us to the next tip. Another 45 degrees gets us to 90. Another 45, another 45, another 45 here, and then that gets us back. So notice that's 1, 2, 3, 4, 5, 6, 7, 8 petals. If we had some other values that were not as obvious, we might have to make a list over on the side and add 45 or whatever our number is each time so that we'll know exactly what direction each tip is in. But with 45s, those pretty much split each quadrant. So if we sketch this, then we end up with a rose with 8 petals. So let's do another one. Let's do one that deals with sine. Let's do r equals 5 sine 3 theta. So since that's odd, we have 3 petals. We've done that before. But the difference here is where it's going to start. Let's not fill that box. So our maximum radius is going to be when sine 3 theta equals 1. So the question is, well, where is sine equal to 1? The first place where sine equals 1, if we're going in the positive rotation, is when our input, not necessarily theta, but when that whole input makes 90 degrees. Remember that sine of 90 is 1. So we need to find out what does theta need to be so that when we plug it in, we end up with 90 on the inside. So if we divide both sides by 3, then of course theta is 30 degrees. So the first tip is in a direction of 30 degrees. 3 times 30 is 90. Sine of 90 is 1. We did this earlier, but if we take a full rotation and divide it evenly among 3 petals, we get 120 degrees between petals. The maximum radius is 5. And we said we have 3 petals. So that should be enough to draw this rose. So unlike the cosines, the sines do not start in a direction of 0 degrees. So we start in a direction of 30 degrees, and our radius is 5. 1, 2, 3, 4, 5. So that's the tip of the first one. If we rotate 120 degrees, that gets us to 150. That's the tip of the next one. If we rotate another 120, that gets us to 270. That's the tip of the next one. So there are 3 tips, 120 degrees apart with a radius of 5. So if we sketch these, we end up with something kind of like this. So there's our 3-tip rose, radius of 5 for sine.